So, rearranging an equation to get it in the form y is equal to mx plus c. And one of the reasons we do this, if we can get a line into this form, we can read off the slope and we can read off the y-intercept. So the equations of lines can take many forms. For example, x plus y minus 2 equals 0. That's the same line as y minus 2 equals minus x, which is the same line. They're all the same lines. It's the same line as this one, x equals minus y plus 2. And this is the same line as x minus 2 equals minus y. All the same lines. Every one of those four are all the same lines in different forms. Again, I could keep going here. More examples of the same line, x plus y minus 2 equals 0. There's another example, x plus y equals 2. There's another example, x divided by 3 plus y divided by 3 minus 2 divided by 3 equals 0. All the same lines. All the same, just in different forms. All the same lines. So if you went to graph them, every one of those would be the same, all the same. And I could keep going. I could give an infinite number of examples there of all the same lines, but they look different. However, none of the lines above allowed me to read off the slope and the y-intercept of the line. To do that, we need to be in the form y is equal to mx plus c. And this special kind of form allows us to read off the slope of the line and where the line crosses the y-axis, or specifically the y-intercept part of it. So we should remember that if a line is in the form y equals mx plus c, we can read off the slope of the line, which is your m, and the y-intercept, which is your c. And this little graphic will get it a little bit better here. Now basically, if we can get a line into this form, 1y is equal to mx plus c, some value of m for the slope, some value of c for the y-intercept. So if we can get it into this form, we can read off the slope and we can read off the y-intercept. See you in the next video for some examples.